Now in this video I am going to solve a problem, integral of a 1 divided by x squared times a square root of x squared plus 1 dx. This integral was solved by blackpenredpen in his video 100 integrals world record, and he made a mistake solving this integral, and that mistake is one that I am going to address today. So this is equal to an integral of a 1 divided by x squared. A square root of x squared we can pull out as common, and we are left with 1 plus 1 divided by x squared. Differential respectful of x. Now, area in which this integral is defined is for all x's which are real numbers and different from 0. Because we cannot divide by 0 and we have x here in the denominator. Of course, x squared plus 1 is always larger than 0, so it doesn't make any problems with the square root of or a fraction. Now our integral becomes an integral of dx over x squared times a square root of x squared times another square root of 1 plus 1 divided by x squared. This is then equal, and right here in this step, at 1 hour 17 minutes and 48 seconds, blackpenredpen makes a claim, don't worry about the absolute value. And that is exactly the point where he made a mistake. So this is dx over x squared times an absolute value of x, and in his solution he doesn't have this absolute value, then a square root of 1 plus 1 over x squared. Now this is then equal an integral of dx divided by x squared times an absolute value of x is equal to x times a signum function of x times a square root of 1 plus 1 divided by x squared. Now just a little explanation. A signum function of x is equal to 1 when x is larger than 0. It is 0 when x is equal to 0 and negative 1 when x is smaller than 0. Basically, for any x which you plug into the signum function, turns the sign of that x. If x is positive, it returns 1. If x is 0, it returns 0. And if x is a negative number, it returns -1. So, signum function of x, well, that is a constant, so it can go in front of a sign of an integral, and we are left with dx divided by x cubed times a square root of 1 plus 1 divided by x squared. Now in this step we are going to introduce a substitution that t is equal to 1 plus 1 divided by x squared, and then we get that a differential respectful of t is equal to negative 1 divided by x to the 4th power times 2x dx, and this is equal to negative 2 divided by x cubed dx. Our integral then becomes a signum of x times 1 divided by negative 2 times an integral of dt over a square root of t, which is then equal to a signum of x times -1/2 times an integral of t to the power -1/2 dt, which is then equal to -1/2 of signum x times t to the power -1/2 plus 1 divided by 1/2. 1/2 and 1/2 are going to cancel out, and we finally get negative signum of x times a square root of t plus an arbitrary constant c. This c is any real number. This is then equal to minus signum of x, and when we return the substitution, we get that t was equal to 1 plus 1 divided by x squared. C, and C is a real number. Now in his video, when solving this integral, blackpenredpen got the following result. An integral of 1 divided by x squared, a square root of x squared plus 1 dx, is equal to a negative square root of 1 plus x to the power of negative 2 plus c. So the difference between my solution and his is this. We are solving the same integral, 1 plus x squared dx, and I get minus sine of x square root of 1 plus 1 divided by x squared plus c, and he gets, solving the same integral, x squared 1 plus x squared dx is equal to negative square root of 1 plus 1 divided by x squared plus c. This signum right here makes a huge difference. Now I want to show you the graphs of both of these solutions. In this graph, you see what the representative function of the solution, which you get for c is equal to 0, looks like. And in this graph, you see what blackpenredpen's representative function looks like. When we put both of these functions in the same coordinate system, my solution is in blue and blackpenredpen is in red. We see that for x larger than 0, we both get the same solution, so there is no problem in that part. But for x is smaller than 0, you can clearly see that our solutions are different. In fact, they are the mirror images of one another, respective to the x-axis. As you can see here, I have the solution, this blue line, in the second quadrant, and the solution that does not exist in the third quadrant, whereas blackpenredpen got it opposite. And that is illustration of his mistake when he said that we don't have to worry about the absolute value. He got a solution which simply does not exist for this problem, and he failed to discover one which does exist, thus failing to solve this integral. Thank you for watching this video. If you have found it to be somewhat useful, please like, share and subscribe to my channel, and I am looking forward to reading your comments. See you in the next video.